Hello everyone, welcome to the ITLS Academy. Today we are going to discuss the topic that is your condensed and evaporated milk. Okay, so the definition of the milk we are already discussed. It is what it is it is a white liquid which are secreted by a mammary gland. Okay, now we are going to discuss about the condensed and the evaporated milk. Why we convert this milk into a evaporated milk or into a condensed milk? Because of increase the shelf life. Increase the shelf life. We all know that the condensed milk and the evaporated milk have a more shelf life than the normal milk. So in today's lecture we are going to discuss about it, and also we are going to discuss the microbiology of microbiology of the condensed and the evaporated milk. So let's start today's lecture. First of all, we are going to see the introduction part. Dairy product of reduced moisture content may be produced so that it will achieve a saving in transportation. Okay, first of all, why we convert this dairy product into a powder form? Okay, so we all know that this dairy product reduces the moisture content. Okay, when dairy products are when milk are used for the manufacturing of the different dairy products, that is your either condensed milk or either evaporated milk, they are what? They are the dairy products. So um, in that type of the milk, what happened, we decrease the moisture content, and when the moisture container decreases, then it will save during the transportation, merchandising cost, and related to the reduced volume and weight. And these products with their greater concentration of the milk solid are also useful in the manufacturing of the ice cream, candies, and variety of other food items. Okay, so in a concentration milk, we all know that the concentration of the milk solid is also greater as compared to the other type of the milk. That's why it is used in the manufacturing of the different dairy product, different products, that is your cream, ice cream, candies, and variety of other items. In some instance, desirable special property result from one or more of the processing operation. Now the next is your, some of these products are little different from our pasteurized milk from a biological standpoint. Okay, microbiological standpoint. Okay, if we take a criteria of microbiological or microbiology, then the different product that we discussed, that is your either condensed milk or either evaporated milk or other type of milk, that is your sweetened milk, they are what? They are differ from the pasteurized milk. Pasteurized milk at the point of microbiological, but heat at a level of commercial sterilization confers that the excellent microbiology keeping quality on a canned evaporated milk. Okay, if we have a good if we have a excellent microbiological, then we have to keep in mind that the canned evaporated milk have a best quality of microbiological point of view. Sugar at a level of inhibitory to most of the microbial growth, retard this spoilage in a sweetened condensed milk. Okay, so in a sweetened condensed milk, what we do, we add a sugar. Now the sugar retard the growth of retard the growth of the microorganism. Okay, where in a dried milk product there is a low ability of water which act as the inhibitory factor with respect to any bacterial spore. Okay, so if we have a sweetened condensed milk, and we have a dried milk. Now, as I already discussed, in a sweetened condensed milk, we add a sugar which inhibit the growth of the microorganism. And in a dried milk, what we have to do, we um, we decrease the moisture content, means that the availability of the water will decreases, and due to which the act as an inhibitory factor with the different bacterial spores or a vegetable cells that have survived the drying process. Now, the next is your concentrated milk. Okay, so the first one is your concentrated milk. We all know that this commonly name is used for a condensed milk. Okay, concentrated milk are also known as a condensed milk, which is prepared for a human consumption after the appropriate dilution as a fluid but without further processing. Okay, so in a concentrated milk or a condensed milk, there is no further processing are done. Here it is simply prepared for a human consumption and after a appropriate dilution as a fluid milk. It is ordinarily prepared from a grade A milk, which is usually at the ratio of 3:1 concentration. Okay, so for the manufacturing of this concentrated milk, we are using a grade A milk, and the ratio of this grade A milk is at the order of 3:1 concentration. Now the processing is done under a condition that satisfy a grade A standard, which including a final pasteurization. Okay, one of the advantages is the reduced space which is required in a refrigerator. Okay, so the main advantage of this condensed milk or concentrated milk is that it reduces the space which is required in a refrigerator. So we have to kept it in so it is not necessary that it should be kept at a refrigerated temperature. It can also be kept in a normal room temperature, but this can be offset by the need of to dilute before use. Okay, so when we have to use this condensed milk or a concentrated milk, first of all we have to dilute it. Okay, without dilution we cannot use it. In addition, the keeping quality needs to be supervised if advantages is taken of less frequent purchase. While considerable scientific and commercial interest was shown in this product in the 1950s, it has not become an important retail product. Now the next is, now the raw milk which is supply for the concentrate is given a heat treatment. Okay, first of all suppose that we have a raw milk. Now this raw milk are used for a condensed milk. Now, before converting it into a condensed milk, it should be a heat treated, approximately pasteurization. And it is then concentrated at a low temperature to minimize the changes in a flavor or a physical characteristic. First of all, when we have to convert this raw milk into a condensed milk, before converting it, we have to pasteurize it. Then after pasteurization, what we have to do, we maintain the low temperature when it converted into a concentrated milk or a condensed milk, so that there is a minimized changes in a flavor or a physical characteristic. Now the concentrated milk is then standardized, homogenized, then again pasteurized before the packaging. Now we have what? We have a condensed milk. This raw milk are converted into a condensed milk. Now after that, this milk are what? They are standardized. Okay. Then homogenized. Then again it will pasteurized. Okay, pasteurization are usually at some house which elevate the temperature around 72 degrees Celsius for 25 seconds. Okay, the common pasteurization temperature is what? It is a 72 degrees Celsius for 15 seconds. But here the temperature somehow vary or elevated. It will be a 79.4 degrees Celsius for 25 seconds, because this component for the slight protective effect of the greater solid concentration. Now the product has essentially the same keeping quality as a pasteurized milk. The increased solid level is not great enough, which inhibit the microbial growth. Okay, so that's why it should be stored at 10 degrees Celsius, which permit the growth of both thermoduric bacteria and any post-pasteurization contaminant. Then the defect encountered are essentially the same as those in a pasteurized milk. Now the next is your bulk concentrated milk. This bulk concentrated milk are usually prepared from a manufacturing grade raw milk, and then it is used as a source of milk solid for the manufacturing of different product, that is your candy product, bakery, ice cream, concentrated yogurt, and the number of other manufactured products. Okay, first of all, this product are what? They are usually made from a manufacturing grade raw milk. Okay, so what the like the raw material are what? Raw material are the grade raw milk. And now this milk are used for the manufacturing of different food product, that is your candies, bakery product, ice cream, concentrated yogurt, and the number of manufactured food. Some concentrated milk may be made from grade A raw milk for use in a standardization of the market milk. Okay, so there are some concentrated milk available in the market which are made up of grade A milk. This product must be processed and handled according to the provision of the recommended sanitation ordinance. Now, condensing is usually at the range of 2.5 is to 1 to 4 is to 1. It depending upon what is the end use or for which it is being prepared. Okay, so condensing is depend upon what is the end use and for which it is it being preparing. That's why the ratio is around 2 is to 1 or 4 is to 1. Now the product is not sterilized during or after the processing. Okay, when we have to preparing this bulk concentrated milk, then it should not be sterilized during or after the processing. So it contain a viable number of microorganism, and the concentration milk solid is not greater enough to inhibit the microbial development. Now the next is your, there is a test which is called a methylene blue reduction test. I hope you will hear about it. With a reduction time of not less than 2.5 hour has been used for the evolution of the raw milk prior to a concentration. Okay, when we have to use a raw milk for the preparation of the concentration milk, then we have to perform a methylene blue reduction test, and this methylene blue reduction test with a reduction time of not less than 2.5 hours, but with a betting cooling on the form. Now, the shortcoming of this procedure for the detection of the psychotrophic bacteria limit its usefulness. Other tests for a microbial quality have now replaced by a dye reduction test in most of the countries. Okay, so in most of the countries, this methylene blue reduction test are replaced and converted into a dye reduction test for the for checking the microbial quality of the milk. If the milk is held for any period prior to the processing, it should be cool at 4 degrees Celsius or below, so that it will avoid the potential buildup of the microbial population and the attendant chances that the acidity or other microbially produced defect could become a problem. Now, heat treatment prior and during condensing are appreciable less than advocate provide a sterile product. Okay, so heat treatment either during the condensing, it is what it is are less applicably, because the Apart from it, we have to provide a advocate sterile product for the manufacturing of the condensed product. Then the cooling, sterilization, and packaging operation, which provide the opportunity for the contamination. We all know that during a cooling, during the sterilization, and during a packaging, they are what? They will introduce the microorganism. It is very common, particularly from improperly clean and microbiologically treated equipment and containers. So what we have to do, we have to use a clean and microbiologically treated component and the container. Otherwise, if we are not using this properly clean and microbiologically treated equipment or a container, then there is a higher chance that the contamination will occur into a condensed milk during the cooling, sterilization, and the packaging. In addition, the materials which is used for the sterilization must be good microbiological quality. Okay, so here one point very important, like the material which is used for a sterilization, it should be a good quality of microbiological point of view, because it must be emphasized that the heat treatment, which effective as they can be a microorganism present at the time of the treatment, which leave no residual microbiological effect to act upon a subsequent contaminant or to limit the growth of the survivor of the heat treatment. Again, the solute concentration in a condensed product is not sufficient that have survived the processing and usually contain a microorganism that have a contaminated the product subsequent to a heat treatment, the time over which the product can be held without the serious microbiological spoilage, which is frequently very limited and especially at an ambient temperature. Now the next is your evaporated milk. Okay, after the condensed milk, we are going to discuss the next topic, that is your evaporated milk. Now, this product has a much in common with a bulk condensed milk through a condensing stage. Okay, so as compared to the bulk condensed milk, this evaporated milk are what? Are the much common. However, it is given a long term keeping quality at a room temperature by a commercial sterilization. Okay, if we prepare a evaporated milk by a commercial sterilization method, then this milk give a like good quality at a room temperature, good quality at a room temperature, either before or after placing in a hermetically sealed container, so that it will protect against a subsequent contamination. Okay, so what we have to do, either before or after we place it into a hermetically sealed container, so that it will protect against a contamination. Most of the product which is made from a whole milk, the federal standard in a United States, it required around at least 7.9% of the milk fat and 25.9% for solid fat in a final product. Okay, so when we get a final product that is called a evaporated milk, now according to the federal standard and United States, they said that um, it should contain around 7.9% of the milk fat and 25.9% of total solid, and the addition of limited amount of salt or stabilization is permitted. Some products of this type are made from a skim milk, and the limited amount of filled milk are made with other fat which replace the milk fat. Now, the Evaporated Milk Association, a trade group of um, manufacturing of the product, which establish a sanitary and other standard. And now these standards also involve a different microbiological tests for the incoming milk, as well as procedure for the inspection of producing farm and their operation. Okay, when we have to control the microbiology of the product, then we have to also inspect the farm and the operations, and some aspect of the processing plant and its operation also are specified. Now the next is your stability of the milk to the sterilization temperature, which is used later, is very essential. Okay, so stability of the milk to the sterilizing temperature. Still, suppose that when we have a sterilizing temperature, then we have to hold the milk at that temperature. Hold the milk at that temperature. It is very important. And the milk proteins are ordinarily stabilized against a subsequent coagulation by heating above the 93 degrees Celsius. Okay, if the milk are heated above the 93.4 degrees Celsius, then the milk present into it, they are what? They are ordinarily stabilized and coagulate, and which hold for us some time. Okay, at 93 degrees Celsius, and it is hold for us some time. This may be done in a hot well with a holding for long as 20 to 25 minutes, but in a larger continuous operation which is enclosed system may be permit the use of temperature as high as 121 degrees Celsius for a few minutes. Now any of these temperature which is used for the destruction of all the non-sporulating bacteria which are present, and many of the less resistant spirulating type, any bacteria that might cause an infection disease would also be killed. So at that temperature, the non-sporulating bacteria will kill, less resistant sporulating types of bacteria will kill, and the bacteria which may be mm, which may be infected or cause an infection disease, they will also be killed. They would also be killed. However, the enterotoxin which are produced by a enterotoxigenic staphylococci, enterotoxin, it is produced by a enterotoxigenic staphylococci, would not be inactivated, and making it essential that the proper precautions are taken so that it will prevent the extensive growth of these microorganisms in the upcoming milk. Now the temperature which is employed are too high so that it will permit the growth of the thermophilic bacteria, so these microorganisms have no not create a problem to the milk product. Now the next is your in the actual condensing operation, whether it is done into a batch or a continuous process. Okay, this condensing operation or condensing process are done either into a batch process or into a continuous process. The temperatures seldom exceed 50 degrees Celsius, and they may be significantly lower under some circumstances. Now, these temperature will not kill those bacteria that maybe survive preheating. Okay, so at that temperature, maybe the bacteria are not killed and maybe survive. Thermophilic bacteria may grow under these conditions, and they may become a factor in limiting the length of time the equipment can be operated before the shutdown for cleaning become necessary. Okay, so the thermophilic bacteria maybe survive at that temperature, so it is very important that the before shutdown the equipment should be clean. Operating of extended period may also result in such extensive buildup of solid on the heating surfaces which is satisfactory cleaning will be made quite difficult. Now following the condensing, the product is homogenized. After the condensing, product is homogenized, and usually precaution concerning homogenizer care. Okay, so we all know that homogenization are done under a homogenizer. So the homogenizer care is very important, must be observed so that it will avoid a excessive contamination from the surface. Okay, because homogenizer may also homogenizer may also become the become the source of contamination. Contamination. Okay, so that's why it is very important that it should be very clean. The product is then cooled and placed in a storage where the final sterilization of the composition take place, holding under a good refrigeration until packaging and sterilization take place. Okay, so we have to keep it at a low temperature, that is in between a 0 to 5 degrees Celsius, so that the microbial growth will not occur. Then it will go to the packaging and then sterilization. So this is very important because the product is not sterile and can thus spoil if the condition permit applicable microbial growth. Because at that time the product is not sterile. What we have to do, we when the final product we get, then we sterilize it. So it is very important that it should be kept at under a good refrigeration condition until it will packed or sterilized. Otherwise, microbial growth occur and it will spoil the food. It will spoil the evaporated milk. Now the next is your can for the evaporated are usually fabricated in an adjacent plant, and the heat which is used for a fabrication is enough so that it will ensure that the can will be contribute few, if any, bacteria to be canned product. Because of the milk is cool when placed in a can, then the sufficient head space must be allowed. Okay, because the expansion that occur during the sterilization process. Okay, when we are filling the milk into a can, this is your can. Okay, and this is your evaporated milk. Now what we have to do, we are going to fill it into. So when we are filling it, we have to ensure that there is a head space. Okay, why we have to leave the head space? Because the when we sterilize it, then there is a expansion occur. Maybe this layer reaches to this, so that's why head space is required, because of that expansion which are occur during the sterilization process. Now the next is your available heat treatment. Okay, so we are going to discuss the next topic, that is the available heat treatment. um, we all know that the available heat treatment are what? Either pasteurization. Okay, in pasteurization it is low heat, low temperature, high time, high temperature, low time, and UHT. Either it is sterilization. Okay, so these are the available heat treatment. Now the historical procedure for sterilization was hold the canned milk for 15 to 20 minutes at 115 degrees Celsius or a slightly. Okay, so when we sterilize the milk, then we have to keep in mind that we have to um, we have to make a temperature 115 degrees Celsius or above for a 15 to 20 minutes. When both the heating and cooling periods contribute some microbiological action as well as affecting the flavor and physical properties. Okay, so both heating process and the cooling process affect the microbiology of the product and also affect the flavor and physical properties. Now both batch and the continuous sterilizer are used, the former usually only in a smaller operation. More recently, the tendency has been to increase the temperature and reduce the time of holding so that it will gain some of the advantages. Okay, we all know that it is what? It is the combination of the temperature and the time. So when we increase the temperature, obviously the time will be decreases. So ultra high temperature treatment will still avoiding the problem of aseptic packaging. So if we use a ultra high temperature, then it will avoid the aseptic packaging problem. However, there, as a technology of the process has improved, then the interest in the UHT heat treatment has increased. Okay, and particularly when used in the combination with the aseptic packaging. Okay, so as the technologies are improved, then the use of this UHT method will also increases, because it give a what? It give a high temperature but less time. Okay, and along with this UHT, if we have a aseptic packaging, then obviously it will like you can say that it is also improve the quality of the product. The heating can be put with tubular or a plate heat exchanger. Okay, so for the heating of the product, we either use a tubular or a plate heat exchanger, which use a steam as an indirect heating material, or indirect injection of the steam into the product, which is followed by a vacuum treatment, so that it will remove the water added by the steam. There are two methods which is employed to permit very quick heating. One is the use of failing film of product, and the next is your its dispersal as droplet. Now the temperature that are effective can only be achieved with both steam and product under the pressure, so that the closed system must be engineered to withstand the necessary pressure. Treatment from 130 degrees Celsius for 30 seconds and 150 degrees Celsius for less than 1 second have been employed. Now the next time temperature combination are selected, and it should be selected such a way that it will effectively kill a normal load of mesophilic spore forming bacteria. Okay, when we select our time and temperature combination, time and temperature combination, then it should be selected in such a way that it should um, kill a normal load of the mesophilic spore forming bacteria and bacillus subtitles. Is probably the most recent of this group. Highly heat resistant, obligately thermophilic strain of the species Bacillus stereo, and other Mophilus might also survive in such type of treatment, probably in a small number as might as flat sore bacilli, but would not be expected to grow or be responsible for the defect under the normal holding condition for the canned evaporated milk. It may be relevant, however, that Bacillus stereothermophilus is capable of forming a biofilm in dairy plants, and hence number could be higher than the expected unless the cleaning regime is adequate. Okay, unless it is a proper cleaning, then if there is not proper cleaning, then there is a higher chance that the Bacillus stereothermophilus can be grow in forming biofilms of dairy plants. When the product is to be held at a higher temperature, and similarly when the load of any type of spore is excessive, a treatment more stringent than the usual might need to be employed. Spores that develop at the optimum growth temperature for the microorganisms that have been reported to be a most resistant, but the pore forming temperature apparently constitutes subleather heat stock that make the spore more sensitive to the final heat treatment. For the more detailed discussion of factors that influence the spore forming, one should consult the classic treaty by Stambo or the text by Burton 1988. Aseptic packaging of UHT product poses a numerous microbiological problem. Okay, after UHT treatment, if there is a aseptic packaging, then that poses a numerous microbiological problem. The container and the closure used must be a sterile. Okay, so for a aseptic packaging, the container that we use or the closure that we use, it should be sterilized, as must the equipment through which the product passes, and the contamination by a microorganisms from the air must be avoided. The container must be hermetically sealed so that air, water, and other source of contamination cannot gain access to the product. Avoidance of the rough handling substitute is to filling is essential because damage to the package or even a temporary weakening of the closure may permit contamination. When the metal cans are used, then they can be a flame heated or autoclave. Okay, if we are using a metal can, okay, then this metal can, what they are, either flame heated or either autoclave with the superheated steam to be made sterile. Glass container must normally be cleaned very thoroughly, and then after that it should be a autoclaved. When the composite plate plastics foil containers are used, then the blanks are customarily treated just before forming the filling under a aseptic condition by the combination of hydrogen peroxide and dry heat. Okay, with the help of this hydrogen peroxide and the dry heat, um, this container should be a clean. The air used for the latter purpose is heated to about 200 degrees Celsius to effectively remove any residual peroxide. Now the next is your examination, microbiological examination of the evaporated milk by the customary procedure is immediately after packaging will usually reveal no viable microorganisms, and the microorganisms seldom which is developed even after a prolonged holding at a room temperature. Now in a past year, much canned evaporated milk has held for 2 to 3 weeks in a warm room so that it will detect the spoilage before a shipping. But with improved technology and the laboratory control, holding of the entire lot is seldom done. Representative can will be held out for the incubation and the examination, where the product is to be shipped to a warmer areas. During that, the incubation of the can should be done at 37 degrees Celsius or 55 degrees Celsius is frequently which is used to detect the faculty or obligate respectively thermophilic bacteria that may be survive during the heat treatment. If the laboratory tests are needed for a small amount, that is around 1 ml of milk, can be removed with a great attention to completely aseptic condition, and it is transferred to the tubes of the sterile bromocerol purple milk, that is a aerobic spore formers, and reinforced clostridial medium anaerobic spore former. The latter tubes are stratified with the wax after the inoculation. BSI 1968 attempts to obtain a quantitative result are seldom made because the presence of the viable microorganism is a criteria employed. The presence of the non-spore forming organism which is used for the indication of the post sterilization contamination, frequently which give a result of a leaky container, but the presence of the spore forming are usually associated with the inadequate heat treatment of the product. Defect, many of the defect reported in the literature and summarized by a um, Hammer and Babel in 1957, are almost never found at the present time because of the improvement in the process technology and the laboratory control by the industry. Microbial defect can be divided into two parts. First one that are due to the microorganisms of high heat resistance which survive a slightly inadequate heat treatment, and the second one those that gain a interest after the heat treatment and which are usually of low heat resistance. Now the next is your most of the heat resistant form species of the genus, that is your bacillus, although on occasionally species of the genus of the clostridium has been encountered. Bacillus coagulans and the Bacillus stereothermophilus may cause a acid coagulation and slight cheesy odor and flavor, and flat soil bacilli which can survive as well. These microorganisms also show a great at 37 degrees Celsius and above, and high storage temperature and at lower inadequate cooling are factor in this type of the spoilage. Bacillus subtitles also cause a non-acid curd which may then be digested to a brownish liquid with a bitter taste. The coagulum, which is formed by a Bacillus megaterium, is accompanied by some gases and a cheesy odor. Gas production are also associated with the putrefaction and smell of the hydrogen sulfide have been reported, which is caused by a Clostridium species, but this type of defect are very rare. Bulge can are also caused, and it is commonly caused by a chemical action of the metal of the can or by overfilling of the can with the cold milk, which then expand on the heating. That's why headspace are important. Contamination subsequent to heating may result in a greater variety of the defect. Leaks in the hermetic seals of the container may be due to the improper closure, subsequent corrosion, or mechanical damage during a subsequent handling. Even a momentary leak may permit microbial entry. Such type of the problem are rare, but if they occur, then the consequences can be serious. So the consumer must be aware of the perishability of the evaporated milk once the can is open. Okay, once a can is not open, then you can kept it for a longer time. But once in a can is open, then you have to know that the what is the perishability of the evaporated milk. The heat treatment which is used to kill the microorganism and provide keeping quality in the unopened has no residual effect that will control the growth of the subsequent contamination, and opening the can under a kitchen condition is almost certain to lead to some contamination. Nevertheless, the product will keep for a survival day under the refrigeration if reasonable care is used to minimize the contamination, but holding without the refrigeration is almost certain permit spoilage is as little as 24 hours. So this is all about the condensed milk and the evaporated milk. I hope you will understand, but if you have any query related to this topic, you can ask me in a comment box, or for a further detail you can follow the ITLS Academy on different platforms, that is Instagram, Facebook, Twitter, YouTube, WhatsApp, LinkedIn, and subscribe our channel ITLS Academy on YouTube and get our app from a Google Play. Or you can also ask your query to the helpline number that I already mentioned in your slide, that is 7080833450. Visit our website www.itlsacademy.com. Thank you for watching. Please like, share, and subscribe our channel.